In here with me are apparatus and full of reagents, and whereby I want to conduct a qualitative analysis of inorganic test. These are the procedures, and this is the inorganic test. We are going to carry out this test, and these are the procedures, and these are the durations and inference where we are going to write. And here with us, if we go through, we are given as a solution of ammonium with this ammonium hydroxide and as a reagent to test the cations. And here we are also given sodium hydroxide, and here we are given aqueous potassium iodide. Here we have the 2 nitrate aqueous and the aqueous diametric. We have that. And also we are given solid S in a stoppered container. Then we have the washing bottle as we are seeing. We have now the 5 test tubes and the 1 boiling tube. And let us start now. And we are starting by, as we are seeing our procedures. You are provided with solid S. You are given solid S now. This is a solid S that is provided. Carry out the test below. We are going to carry out the test below and write your observations and the inference in the space provided. We are going to write our observation in this space and our inference in that space. And in the space provided. Now, if we start with this A, and it is saying place all solid S in a boiling tube. Here we have a boiling tube, and we are going to place it in a boiling tube. Let us do that. So this is solid S, all solid S in a boiling tube, all solid S in a boiling tube. So this is solid, all solid S in a boiling tube. After in boiling tube, then add about 10 steams of distilled water. So we are going to add 10 steams of distilled water. Here is a measuring cylinder, and sorry to forget that. Here we have 10 steams of what? Of distilled water. So that is distilled water. So then we check so that we want it to be solid, because we can't carry out our experiment in a solid. We want to have a solution or a class. So the solid must be dissolved so that we can carry our experiment now. Okay, the solid is going to dissolve. That is now the solid is going to dissolve. Solid is going to dissolve now. Now they sit and shake well. We are shaking well and take that until all the solid dissolves. All the solid dissolves. So we are told until all the solid dissolves. Now our solid dissolved. Now after that we are told and write the observation. Okay, as we are seeing, this one is the solid dissolved to form a colorless solution now. It's clear now you are seeing. So how to write that? So you can write solid S dissolved and the solid dissolved in water and forms a colorless solution now. A colorless solution. So what is the inference now? When the solid dissolves in water, what is the inference? In fact, there are two solids. Solids either will dissolve or will not. Will dissolve soluble salt. Will not dissolve in soluble salty present. So here we write soluble salty soluble salt resin. So it means now the solid S is up. It's a soluble salt. Good. Now from there, we were told now use the solutions for the testes below. Now I have how many testes? I have 1, 2, 3, 4, 5. So it means now I have to divide my solution into 5 test tubes. Into 5 test tubes. That is 1. Yeah, I'm dividing the solution from the boiling tube into 5 test tubes now. Into 5 test tubes. Okay. So now I have divided into 5 test tube. Good. Then to about 1 stimpter of the solution in the test tube, add a pure sodium hydroxide solution until in excess. To about 1 stimpter of the solution in the test tube. Add, for example, let me measure 1 stimpter of the solution in the test tube. 1 stimpter. So 1 stimpter, about 1 stimpter, about that. So about 1 stimpter of the solution. So I will add sodium hydroxide. So this is my sodium hydroxide. They say add sodium hydroxide dropwise. So let me add dropwise. Dropwise is that you are seeing white precipitate, formation of white precipitate. Let me add in excess, yeah, in excess, no limit in excess ونزلت in excess, the solid is going to dissolve now. I see now. The white solid is going to dissolve. Yeah, in excess. So what form? White precipitate formation of white precipitate in few drops which dissolves in excess in sodium hydroxide. So that means the white precipitate formed in few drops and it dissolved in excess. If dissolved in excess, it's like that. Dissolved in excess. Good. So how do you write now? Here, when it is this one is done, now we are going to write. Remember this. Remember this. Look here. If, for example, you are using sodium hydroxide, it will be like this. I normally tell my students like this. So when you are using sodium hydroxide, when you add, it either becomes colorless, it can form colorless solution, or can form color. The color can be blue, can be green, can be brown, or the white precipitate in few drops can dissolve in excess, or white precipitate heliums can dissolve in excess, or can does not dissolve in excess. If it dissolves like this now, so to your information, we have added sodium hydroxide. We have not seen this. We have seen white precipitate. So the white precipitate, we have seen white precipitate in few drops, but dissolve in excess now. So we have to write cations there. So now students, if it is this, that one is the sodium ion, potassium ion, and the ammonium ion. If it is forming solution with sodium hydroxide, that is the white precipitate means this color solution form, these cations are given. If it does not dissolve, that is magnesium ion, barium ion, and calcium ion. So these three. If it dissolves, that is zinc ion, aluminum ion, and what? And lead ion. That is now the inference. If it is blue, that is copper ion. If it is green, that is iron 2 ion. If it is brown, that is iron 3 ion. So are you see now? So which now category will we go? So from sodium hydroxide, we are up to here. Then we are the sodium hydroxide dissolved in excess. So it means now these three are present. So you come here and you write sodium and zinc ion, aluminum ion, and lead ion present, isn't it? So you go like, that. Good. From there, let's go to the next one. Next one is to about 1/16 of the solution in the test tube. To about 1/16 of the solution in the test tube, and add 2 mole of ammonia solution rubber antimatter. So will be the same. So it means we'll take the 2 solution in the about one. So that's the one. So it means add ammonia. Ammonia is here. Let's add rubbers. 1, 2, 3 drop. So you see now white precipitate, formation of white precipitate, Let's dissolve in excess. Let's add in excess. I see the white precipitate is resisting. It is persisting at the bottom. I see in half a video. So that means now white precipitate does not solve. Good. If white precipitate does not solve, how will you write? So here you write formation of white precipitate. Formation of white precipitate, which is insoluble in excess, which is good, which is insoluble, and we cannot which is insoluble in excess ammonia, ammonia. So when you have that reference, my students, this ammonia is coming to narrow down the first test. The first test we use sodium hydroxide. We suspected the three zinc, aluminum, and lead. So therefore, if we have suspected those, and now the cations were to off. They were 3, 3, 3, 3. So it means now they were 5. So again, when it is ammonia, we go like this also. We go like this with ammonia. When it is ammonia, when you are using ammonia, the white crystal is going to form. If you drops in excess, the color there, this one there, only that, what happens is, the zinc will be only the one that dissolves both ammonia and the sodium hydroxide, but the aluminum and lead they are going to join here. So aluminum and lead they are going to join here, while calcium is going to join this part. I see now. So look now, look this cations, look this cations. This is ammonia now. When you are using ammonia, what happens is, formation of white precipitate, it dissolves in excess, that's only zinc. Formation of not white precipitate, it cannot dissolve, that is the emulsion barrier, lead aluminum. And formation, no colorless solution, colorless solution form, sodium ion, ammonium ion, and the potassium ion, and calcium ion. Others are the same. I see now. So this is what happens when ammonia is added. So what happens, students, is this. How will we write? So we will ask ourselves. There were those which are here, then again they are here. So it means now white precipitate form does not dissolve. So it means now neither magnesium nor barium are going to be there, but the only suspected are lead and aluminum. Because lead and aluminum are there in the other place. So it's a lead, aluminum, and lead which are going to be present. Good. Let's go to about 2 centimeter of the D. To about 2 centimeter of the solution in the test tube. Add 2 to 3 drops of the aqueous potassium iodide solution. Potassium iodide solution. 2 to 3 drops. So what happens, students? We are going to do that. Let's do that. Let's do that. This is potassium. This is now the potassium one. The potassium iodide. Now the potassium iodide we are going to add. Are you seeing now? 1, 2, 3. 2 to 3 drops. Are you seeing any change? No. So it means now there is no formation of white precipitate. There is no formation of precipitate. In fact, why we are using potassium iodide is because of we are looking the yellow precipitate. It forms the lead. So because of we don't have white precipitate, yellow precipitate, we were expecting yellow precipitate, but we will not say yellow precipitate. We are expecting yellow precipitate, but we have seen no white precipitate, but we will say no yellow precipitate. We were expecting that. Good. So how about Tanika? No formation of yellow precipitate. Yeah, no formation of yellow precipitate. That's what we're going to write. My students, listen, let me repeat again. We were expecting yellow precipitate, but we have not seen the yellow precipitate. So what are we going to write? We are going to write no yellow precipitate. No why? No yellow precipitate. Good. If there is no yellow precipitate, means now lead ion is absent or aluminum ion is present, isn't it? Yeah. Aluminum ion is present. So means we will take the aluminum. If there is formation of yellow precipitate, we will say lead ion absent. Aluminum ion So this is because of aluminum, it was aluminum was here. Good. If you say lead iron absent, no problem. To about 1/16 of the solution in the test tube, add 2 to 3 drops of barium nitrate. Okay, let's add. So this one is 2 to 3 drops of barium nitrate. Let's add 1, 2, 3. Look, my students. Look. No formation of hydrogen. Barium nitrate was to test the sulfide and carbonate, but no formation of high precipitate. It means loose are absent. So here we write no formation of Y. B. No formation of high precipitate. Then here you are going to write the sulfate, sulfide, carbonate are absent. Yeah, that's what we're going. That's what we're going to write. Good. The last but not the least, they are saying to about 1/16 of solution in a test tube, add 2 to 3 drops of lead nitrate solution. Lead nitrate solution. So how will we add that? So this is the add lead nitrate solution. So this is the lead nitrate solution. So let's add 2 to 3 drops. 1, 2, 3. See now? Formation of white precipitate. That is what we call white precipitate, my students. So that's the formation of what? Formation of white precipitate. So that is formation of white precipitate. So it means now, if there is formation of white precipitate, sulfate, sulfide, carbonate, and chloride were going to be present. But because of we have said sulfate, sulfide, and carbonate are absent in our procedure E, we cannot say they are again present. So what we do is the one which is